Today we'll discuss the differentiation of product of three functions. The questions are as follows. So please pause and try these problems yourself, else view the solution. Solution to problem number 1. Here we'll find ddx of these three different functions. The rule is differentiation of one function at a time. The other two will be kept outside differentiation. See here, x to the power 5 is differentiated, the other two kept outside. Similarly, here e to the power 2x is differentiated, the other two are kept outside. And in last one, log 3x is differentiated and the other two kept outside. This is nothing but application of the differentiation formulas, nothing new. So we are simplifying all this. So this is the final answer. Now solution to problem number 2. Here also we have got three different functions and the same method will be applied. Only a new function we are considering a to the power x, that is 7 to the power x. Its formula is 7 to the power x log 7. So all those formulas so far we have discussed, you have to remember to solve these sums. Solution to problem number 3. Here three functions are root x, 4 to the power x, e to the power minus 3x. Root x needs some extra discussion here. Rest two are simple standard function. So as usual, one at a time will differentiate these functions. Now in case of root x, ddx of root x, we'll write 1 by 2 root x. Here we are not going to show all the steps. These steps I am just discussing here. ddx of root x is equal to ddx of x to the power half index form, and half x to the power half minus 1 equal to half x to the power minus half equal to 1 by 2 root x. If we will write all these steps here, it will be very complicated. In these two cases, 4 to the power x is directly 4 to the power x log 4. E to the power minus 3x is minus 3 e to the power minus 3x. But in this case, if we show all the steps, it will be very lengthy. So whenever we have got a big sum like this, where root x is a part, we will directly apply this formula. Now, if we are given a sum where only differentiation of root x is required, in that case we can show all these steps. So keep in mind, whenever or wherever is required, sometimes we will directly use this type of formula. In simple differentiation, we can show all these steps. Now we are taking common factors out, and this is the final answer.